Let's skip over to problem 3 because it's also a mixing problem. Anything like a manufacturing where I'm trying to decide how much of different items I'm going to use in the manufacturing process, that's basically the same as the gasoline mixing problem that we had on the exam also. Okay, so on the exam, we said we had this gasoline company that had these facts about cost per barrel, so on and so forth. And we had this other piece here. Again, we're going to try to maximize profit. We've got 2 products that we sell: a regular gasoline at $21 a barrel, 90 octane, and a Supreme gasoline at $27 a barrel, 97 octane. And we make these 2 products by mixing these 3 inputs. Okay, and this is as real a manufacturing business question as I can imagine. I've been, like I was sharing early in the call, I've been in beverage manufacturing and bottled water, soft drinks, and things like that for 29 years. And it's a real thing to make choices about, hey, am I going to use high fructose corn syrup or sucralose in making this 50,000 gallon batch of cola, or some blend of the 2, because they cost different. They get slightly different taste results, which is kind of analogous to the octane. And you want to be profitable and still hit your taste requirements. But this is kind of where we start. All right, so can anybody articulate what about this problem made it hard for you to get started here? Or do you want me to kind of take my usual approach again? What is your thinking?
I think if you just take your usual approach, that would be beneficial for me.
Okay.
I'm not even really sure where I where I was struggling on this one. But.
Yeah, and I might lay this spreadsheet out slightly differently than I did in the answer key, so you can see it kind of dissected 2 different ways. Yeah, I'm going to put all the decision variables side by side. Okay. So one of the things I saw several folks do, and I think Jesse, you might have done this too. The data that's in your table is already organized this way. When you start putting your decision variables in, I do recommend having them flow in the same direction. So if you think easier with your decision variables going across a horizontal array, I would take the time to flip this data table to be lined up in the same way. Okay.
That was a question I had. Sorry to interrupt,
Yep.
but when you input those arrays, this may be a dumb question, but when you input those arrays into Solver, if you do a column and a row, does it still translate the same way, or does it have to be a column and a column?
It can be a column and a row, but it interprets columns top to bottom and it interprets rows left to right. So as long as you are diligent about that analogy, it'll still work. I personally think it's hard to troubleshoot a big spreadsheet if you've mixed the 2 together. Are y'all okay with me leaving these vertical like this? All right, so what I'm going to do then is this. I'm going to say I'm going to have a regular mix plan and a Supreme mix plan. Okay? These are the variables that I'm going to let Solver manipulate here in a few minutes. Okay? So in here, this is going to be a quantity of input 1, a quantity of input 2, and a quantity of input 3. And I've aligned them this way because here in a minute we can start multiplying some things together easily and getting some totals out of what's out here. All right. So again, I very much like putting dummy variables in here so that when I build formulas off of them, I can see if the formulas make any sense. It's easier to find typos. Okay. So I'm going to do that. I'm going to stick with my usual silly dummy variables. I like the 5, 10, 15 thing, but I'll make them 2 different directions. That's just to have numbers in there to see if my formulas work. Okay, now to get to a solution, we got to think through this. What are the things that we're trying to compare and trying to do? I need to hit at least 300,000 barrels of regular and 450,000 barrels of Supreme. So I know I'm going to need to sum this up to see how much regular I'm producing. Okay, so I'm going to do a sum here and here, and I'm going to label it so I don't forget what I put in there. Okay, so here later in Solver, I'm going to say that this number has to be at least this number or greater. Okay, that way I'll know that I got this populated. And this is kind of how I think you should think about Solver: is out of your data table, keep looking for, have I built everything into a reference table and had it tied back to these variables that's necessary for my for all my criteria, my constraints that I have. Okay. Next, I'm going to think about profit next. So how am I going to find out how profitable each one of these is? Okay. So I have a cost associated with it, and then I have a sales price. Well, the sales price is based off of these totals. So I'm going to sell my regular, all of my regular, at $21 a barrel. However, as I put in input number 1, I'm going to put it in at $17.25 a barrel, and input 2 goes in at $15.75 a barrel, and so on. Okay, so a very legitimate way to do this is to say what profit would get generated, or what sales are generated if I sell this 30 barrels, right? So I'm just going to start with the sales first. I'm going to separate the two, the sales and the cost. So the sales is simply the barrels I produced times this neat sales price I get for my regular, right there, right? So I would, in this, using the dummy numbers, I would get $630 for selling all the regular that I produced. And now I can do the same thing and say my supreme is at $27 a barrel, so it'll generate $810 in sales. Okay. Now, I'm going to go ahead and put the grand total of those two here over on the right. Okay, if y'all will permit that. So I'm going to sum those two together. So for all the gas I sell, it's $1,440. Okay. Now, what's my cost? Okay, this is where a few people stumbled a little bit on the exam. Well, in this case, we can go ahead and use that nifty sum product formula that we talked about earlier. Because if we take this 5 times 1725 plus 10 times 1575 plus 15 times 1770, I can do that in its own column, or I can use a sum product. This array times the cost array. So my total cost is $509.25. Okay. Now doing that again for the supreme, I can highlight this array, comma, this array, and I get my total cost for my supreme. Now you can see where my brain's going. If I then add my two costs together, subtract my cost from my sales, I get my profit cell right here. Okay, I'm going to highlight that one as well. That is what we're going to try to maximize in Solver in just a minute. Okay, make reasonable sense so far? Yeah, and this, I'll tell you something that would be really helpful, and hopefully this video is going to come out clear enough that it's very usable for you guys, is start with a blank spreadsheet and build this from scratch again and walk through the whole thing with the video piece by piece and play with some stuff along the way. So now I'm suddenly wondering, I can't remember if I have to do, so a lot of functions in Excel have variations on the function, and I don't remember if this one requires a modifier or not. It would. Okay, so there is a way you can multiply repeated columns times a single reference column, but it's not the plain sum product, so forget what I was about to do. All right, now the final thing we've got to do is see, did we get 90 octane out of the regular mix, and did we get 97 octane out of the supreme mix? This was the most common errors that happened in folks' spreadsheets. Okay. So how would we model that octane? Well, it's basically a fractional equation. So if I take, and I'm gonna, from a mixing standpoint, I'm gonna push pause on this specific problem and talk to you guys about doing mixing. And I'll put this in here as text so you can see it. So if I've got just an algebra standpoint, if I have a quantity of item 1 times I'm going to call it a strength of item 1. You know, we could even be talking about, you know, solutions of hydrogen peroxide, or, you know, who knows what it is. Okay. And we add that to plus quantity of item 2 times the strength of item 2. Close that out. So that's a total on the numerator, right? So quantity of item 1 times strength of item 1 plus quantity of item 2 times strength of item 2. If I divide that by quantity of item 1 plus quantity of item 2, you'll get the fractional strength. So the only term that's left at the top is the strength term. All the quantity terms cancel each other out. Okay, and you get that blend. You can look at it as a mixing equation or a blending equation. And I'm going to let that park there in text so you can see it. Okay. Now there's two ways we can get there, and I'm going to do the long way first. And this is how most people that solved this problem did it. They simply totaled up how much total octane ends up in this sum of the number of barrels I created. And that's the idea that once again, I can use the sum product. In fact, I'm going to label it similar to how I did before. So, well, I'll make this so that I can type a longer word. So this is the sum of octane times barrels. Okay. So again, if you use the sum product, how many barrels of each array multiplied times the octane of each array. And this is not going to give you your octane rating. What this gives you is in 3,030 barrels, there's 3,020 octane units. Okay. Then, if I divide that 3020 by how many barrels I made, it will give me my octane rating. Okay. You can just write a formula all in one stroke to do the whole thing, this fractional formula, but this is basically using the distributive property in algebra of this fractional formula. So we come up with a solution. This is the singular item that more people missed on the exam than anything else. So does that mixing of strength of items make sense to you guys? Or would you like me to build it in a formula like this so you can see it? And I'm happy to do that too.
Whenever you did the sum of octane times the barrels, okay, sorry, I just wanted to see that formula again.
Bet. Yeah, I just did sum product of this mixed plan array times the octane array. Okay, that would be the same thing, so that you can visually see it. I'm going to go ahead and hop over here, and I'm going to claim this as my show the mixing. So I'm going to make a I just did a quick paste there. So if I wanted to see everything that's happening and not use a sum product, I would say that the regular mix plan, the amount of input 1 times the octane rating of input 1 means that I have 500 octane units being contributed by input number 1. Okay. And it would come down like this. Okay. Then if I summed those things multiplied together, it's that same 3,020 we got with the sum product before.
Okay, that makes sense.
Okay.
Thank you.
Yeah,
Sorry.
no, please ask those questions, because sometimes it's not intuitively obvious at first, And like I was talking about riding a bike earlier, once it becomes intuitively obvious, you're like, I can't believe I didn't see that before. And it'll be in your brain
Yeah,
forever.
some things are clicking.
Okay. You know, this, you would potentially do the same thing here on the Supreme Octane if you wanted to. Whoops, I don't need a question mark in there. What's wrong with my fingers? Already thinking about movie night. Most of my family's out of town. Only my 19-year-old is a just finished her freshman year at OC, and she's my only kid that's home this weekend. So we're going to have movie night tonight. Yeah, so I could add that one up there, or I could do this same over here. Make sure you see it. So I'm going to do the sum product again. The Supreme Mix Plan array multiplied by the octane rating array. And that gives me 2920 octane units in that case. And same thing if I divided it out. And these are because there's dummy numbers. Right now, the Supreme is coming out lower octane than the regular. But you know, when we run the model, it won't do that. Okay, so that's how much octane. We want to maximize this. We've got to hit this. We've got production quotas. We can make this run now. Now, a warning I gave in some of the other videos is Solver. Well, I'll just show you. So Solver sometimes will use zeros and start from 0 to see what the solution is. If Solver goes to 0, you get this pesky little divide by 0 error. Okay? If you get a divide by 0 error, even for a split second while Solver is running, Solver will stop and it will not finish the problem. Okay? So anytime you've been trying to use it and you get frustrated with Solver because Solver encountered an error, there's an error on the spreadsheet, my opinion, 99% of the time, this is what happened. In order to solve the problem, you had to divide by something, and Solver inserted a 0 for that something, just long enough for your model to crash. Okay? What do we do about it? There's a bunch of things you can do about it, and I showed this in one of the other videos. You can use the if is error term. I'm going to type it down here as text so you can see what I'm talking about. There is an if term that exists that compares two things. If this first, if this item is true, then it returns this first value. And if it's not true, it returns the second value. Okay. If I am then clever about it, I can then nest and what's called the isError function and refer to some equation. And if that returns an error, it's going to return this first value. And if it doesn't return an error, what I do that I feel like is really clever is I do that same sum equation that I was wanting in the first place and let it run. Okay? So I am going to insert that same logic right here on this equation so that even though those are zeros, it'll return something else. So I'm going to do my if and open that up. isError. So if I get an error out of that equation that I just referred to, it's going to return the true value, okay, to the if function. So I'm going to make it return the number 1 million. And there's different kinds of logic you can hear. A lot of times I'll put just a 1 in there because all I want is for the model to not crash. If for some reason it repeats returning an error, it'll show 1 million, which is too big of a number for this model. So it'll be obvious. And if it doesn't fault out and have an error, I want to know the answer to that equation I had in the first place, G15 divided by G10. Okay. Put my bracket on there. Boom. So you can see, while I've got zeros up here, it returns that million. And as long as it's not dividing by 0, it gives me an actual answer. Okay. This is not absolutely necessary in these models. This model might run just fine without it. I don't know. In fact, I'll find out because I'm not going to give the same protection to the equation right next to it, which also could end up with a divide by 0, and just see what we get. Okay. Y'all got questions on that or back here on this mixing or any of that stuff? Okay, I'm going to make this column wider too. That's going to be a big number. All right. And I get it. Somebody else on one of the other calls is like, I cannot believe this class is offered as an asynchronous online class. I agree with everyone who's had that thought. I cannot believe this course is offered as an asynchronous online course. These concepts are difficult without being able to be in a live classroom. And in fairness, this is the very first time I've taught an asynchronous course. Typically, if I've taught adjunctly in the past, it's been in person. All right, so let's go to our solver and let's see if we get all our criteria in there. Okay, so my objective is that profit right there. I want to maximize it. And I want to maximize it by changing these 6 cells, the mix, for the regular mix plan and the supreme mix plan. Several folks are still struggling with the idea of how does Solver know which one's regular and which one's supreme. It doesn't, and it doesn't care. All it cares about is, did it satisfy all the constraints in the model? Can all the math on the page work as this number gets bigger and bigger? And how big can I make this number before all the math on the page stops working? Okay? I just realized we have to add one more constraint in here before we can actually run the model. So we're going to optimize that by changing those cells, and I'm going to go and close this. So I forgot a constraint. We only have a certain number of barrels available. One student forgot this constraint on the exam. Almost everybody forgot the parallel constraint out of the homework. So the bond problem in the homework is the exact same logic as this problem. It's mixing different bonds together to get a result. More than half the class spent more money than the problem said they had on bonds, and and all I had to do was add that one constraint, and everybody's models worked correctly. So I forgot to put this in here. We have a total barrels used, right? So for each one of these, and there's a couple ways I can do this. Well, no, it's just summing those two. I was thinking about the other way I structured this page. So if I sum those together, I know that I used 20 barrels of input number 1 out of the 180,000 barrels I have available. Okay? Makes sense? And do y'all feel like you forget those exact same constraints sometimes? So there's those constraints. Now I'm going to go back into my solver. All right. And here's my objective cell again. By changing these cells, and I'm going to start putting constraints in. Okay? And I'm actually start with the one I just finished with. So these that are calculated, the barrels used array must be less than or equal to the barrels available array. Okay? So this 20 must stay below 180,000. This 20 must stay below 350,000. So on and so forth. Let's add the next constraint. The amount that I produce, this total regular produced, right here. I forget how they phrased it in there. In my own test, I forget how I said it. It must be greater than or equal to this 300,000. I need at least 300,000 barrels of regular. I'm going to add. Must be greater than or equal to. I need 450,000 barrels of supreme. Let's add another constraint. This octane rating I calculated for regular must be greater than or equal to this octane rating for regular. And you can see if I organized my spreadsheet a little differently, I could have highlighted the arrays in both these cases, but because I didn't, I don't want to just highlight down and across. I think it works, but I'm going to do these one at a time. And then my calculated octane rating for supreme must be greater than or equal to my octane rating for supreme. All right, so let's think here for a minute. We've got our barrels available compared. I've got my total production compared. I've got my octane rating compared. We think we're ready to solve. So this one is going to have some dislinearities, I believe. Anytime you have two separate mixings, it won't run very well on the linear problem. You can do some things to make it linear, but I'm going to go ahead and run it as nonlinear. Let's see if it runs or if I forgot something. Keep the solver solution. So that's the solution if I go unconstrained and I overproduce. I think on the exam, did I say exactly these barrels? Because that doesn't match. I think that's what the difference is. So I'm going to look now at this G10 constraint compared to B18. Oh, I see two mistakes I made in here. So I referenced G10 twice, and I didn't constrain. So I referenced this cell twice. I didn't actually reference the supreme cell on the productivity. So I'm going to take out both of those that are in row 10. And I'm going to redo them. All right. So this production of regular, I'm actually going to say must be equal to my required production of regular. I'm going to add my production of supreme must be equal to my required production of supreme. Click OK. Solve. And that makes me more comfortable because that's the answer I claimed is correct in the answer key roughly. There is a very slight rounding difference, and there's a very slight difference. So depending on how you build your formulas down here, and this is a call I've got into a colleague on how do you troubleshoot this if you want to get extremely detailed on the answer. So based on which algebra you choose and how you stack your algebra, you can get very slightly different answers on your optimization and very slightly different mixes on your constraints here. So the oops, looks okay. So this one we just worked. You would have gotten 100% if you got these solutions on the exam. Let me fix this. Okay, stop it. Close. There we go. Now the columns are visible. So that's the solution we just came up with. The answer key I sent out to you guys shows that there is slightly more profitable version. I've got to play with this a little bit and understand why it can be a little different in one model to another, and something you guys should do a little bit. This will give you a little more familiarity with how your own model works. So if I've got another solution that I know is nearby, I'll put the dummy values in that's close to that solution, and just see if this model will center in on that solution. Because sometimes there are two optimizations that are very, very close to each other mathematically, and depending on what dummy values you start with, Solver will stop at one of them or it'll stop at the other one. Do not let that distress you. That's not the point of these exercises. The point of these exercises is getting to where you can build a model like this that you can then play with. Because in the business world, depending on what route you guys go, you will be trying to optimize some things. You'll be trying to optimize, where you're putting things in warehouses, how much of different products you're using. So now I'm going to run Solver again on our model with different dummy values forced in there. Yep, and super interesting. So this time it comes back with an answer that is closer to my other model. It did this right here because it's nearly a zero. You got some little rounding errors showing up in there. You can make your model stop doing that with that same piece I showed you earlier of adding a constraint, saying, hey, I don't want any scientific notation near zero nonsense. I want integers. So what if I say it has to be whole barrels only? Solve it again. And it fixes it. And that's the answer you saw in my answer key. So for some reason, if I start with my favorite starter dummy values, it gets a slightly different answer. Whoops. Have you guys seen that? Has that confused you, or did I just add to the confusion by pointing that out? Yep. Well, that time I go back to my original dummy values, and it gave me the more optimized solution. So one of the things I definitely want you to stick in your brain is this solver is not specifically doing all the algebra on the page. It's inserting estimates, and it's iterating through thousands of estimates and comparing those to, does the model still work, or have I violated math rules to get there? And as long as the model still works, solver is happy. Okay, so when you work problems like this, if you get very subtle differences, in the mixes here, but you get similar answers on the solutions, you're within the margin of error of solver. If you want to get more specific than that, there's a different aftermarket solver you can add to Excel. All right, questions on this one?